I am exerting some force to the duster. Then the duster also exerting same force on me. That's why my hand is coming up. I am exerting force and the duster also exerting force. It means here we are applying same amount of force but in opposite direction. We are applying same amount of force but in opposite direction. It means here the Newton's third law of motion. It explains that the object, for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction. So when we exert, see on the slide, it explains what happens when one object exerts a force on another object. If an object exerts a force on the other object, the second object also exerts same force on the first one with equal magnitude. See the slide, friends. It also exerts same force. Okay. And next, okay, now let's do another activity. What is that? See, example for Newton's third law of motion. When we are riding a bicycle, yes or no, when we are riding a bicycle, then what happen means, the bicycle, when the tires of the bicycle moves the ground, pulls the ground back. Okay, this is the action, and the ground pulls the bicycle tires forward. This is the reaction. So they are exerting same force, the tires and the ground, but in opposite direction. So this is the Newton's third law of motion can be simply said as action and reaction. Action and reaction. Newton's third law can be simply said as action and reaction. Okay, friends, see on the slide. What is this? Ball. See here once. See, what is this? This is a ball. When I throw this ball towards the wall, does the ball stick there? No, it comes back from the wall. Yes or no? See here, when I throw this ball towards this, what happened? Does it stick here? No, it come up. Yes or no? So throwing the ball is the action and the ball coming from it is the reaction. Action, reaction. Okay, friends? Okay. So see on the slide, it is simply said as action and reaction. And rocket, jet engine are also example for this. When rocket is moving in the space, it expels a gas. Yes or no? It expels a gas, because when it expels a gas, then the gas exerts some force to the ground. It exerts some force to the ground. See here, friends, rocket expelling the gas, and the gas exerts some force to the ground, and the ground also exerts some force to the rocket. That's why the rocket can easily move into the space. Okay, here also the action and reaction process is going on. And see, what are you observing here? A person swimming in the water. When we are swimming in the water, then also the action and reaction only helps us. How means, when we are swimming, we pull the water back with the help of hands, and the water pulls our body forward. So in opposite direction. So pulling the water back is the action, and the water pulling our body is the reaction. And not only for us, friends, for birds to fly in the sky, fishes to swim in the water, also Newton's third law helps. See here, what are you observing the picture? What are the pictures about? Birds flying. Yes or no? Birds are flying in the sky. When birds are flying in the sky, they pull the air down with the help of wings. They pull the air downwards with the help of wings. This is the action. And the air also pushes the wings of the bird upwards. This is the reaction. This action and reaction combines together and help the birds to fly in the sky. And next, see again the slide. Here we are seeing that fishes are swimming in water. When fishes are swimming in water, they pull the water back. This is the action, and the water pushes their body, pushes the fish forward. This is the reaction. So friends, everywhere we are finding the action and reaction. Yes or no? Yes. And in games also we can find action and reaction. How means, see here, what are they doing there? They are exerting force. This person exerting force to him, and he is also exerting force to him. They are applying same force but in opposite direction. Yes or no? Yes. And okay, friends, now let's see a video. This is also a very interesting video which explains us about Newton's third law of motion. See here, he was riding a bicycle. And we know that for every action there is an equal and opposite reaction. When he throws the ball towards the ground, throwing the ball towards the ground is the action, and the ground also exerts same force to the ball and the ball come up. This is the reaction, action and reaction. So friends, and when we are riding a bicycle, then the tides of the bicycle pulls the ground back. Just now I have shown you, this is the action, and the ground pulls the tides of the bicycle forward. This is the reaction. Okay, this is the action and reaction. Now let's see some more examples here, friends. What is this ball? When we throw this ball towards the ground, it comes up from the ground. Yes or no? So this is the action and reaction. And let's do one activity, friends, here, lab activity. To do this lab activity, I have taken a laboratory stand, candle and test tube and a rubber cork cap. I took a small quantity of water in the test tube and I closed the test tube with the rubber cork cap. And now I am lighting this candle. Let's see what happened. Here in this activity, we are going to observe the Newton's third law of motion. It means the action and reaction. Action and reaction. Okay, I am lighting the candle here, and let's wait for some time till the water becomes heat. Okay, friends, until let's discuss other activities. And see here, what is this? What is this? This is a balloon rocket. I prepared a balloon rocket. Here also, in this balloon rocket also, we can find the action and reaction. We can find the action and reaction. When I release this thread, then what happens when I remove this thread? The air releases from the balloon and the thread of in this straws will come backward. It means here they are taking in opposite direction. So this is one of the model of Newton's third law of motion. Okay, now let's see a video. See the video here. This is also about Newton's third law of motion. Friends, by seeing this video, observe how many laws are where we are finding the Newton's third law of motion, the action and reaction. He was riding a bicycle. There also we can find yes or no? Yes. And the wings of the butterfly, it pulling the air downwards and the air pulling the wings upwards. Here also we are finding the action and reaction. Okay. Observe the video, friends, carefully. When he was riding bicycle, and here the Newton was playing with a ball. There also we are finding action and reaction. Yes or no? Yes. See, observe where we are finding the Newton's law of motion, third law of motion. Okay. See, friends, see on the slide. Here in this video, here also we can find Newton's third law of motion. See how means when the boy come out from the cannon, then he was going up into the sky. There is it is the action, and the cannon come backward. This is the reaction. It means for every action there is an equal and opposite reaction. Okay, friends, and see the video again. See. And when we sit on the chair, then when we sit on the chair, our body exerts a downward force on the chair, and chair also exerts an opposite upwards force on our body. So here also we are finding the Newton's third law of motion. Okay, observe, friends, if a chair does not exert force on our body, then what happens? Let's see. If chair would not have exert force on our body, then the chair will collapse and we would never able to sit on the chair again. And see, when birds, I told you, Newton's third law helps the birds to fly in the sky. Yes or no? Yes. See, let's how the Newton's third law helps the birds to fly. See how the bird is flying in the sky. It was flying happily, no? Newton's third law helps the birds to fly. Wings exerts a downward force on the air, and the air also exerts equal and opposite force which pushes the bird upward. So, here we are finding the action and reaction. This action and reaction combination helps birds to fly in the sky. Okay friends, this is the video Newton's third law of motion. And okay friends, now let's see the activity what happened. The water is boiling in the test tube. We have to wait for 15 to 20 minutes because when water become very hot, then the water vapor present in the test tube, and the cork will come forward. Let's do it. And see here, what is this? This is a butterfly, model of butterfly. Yes or no? Yes. So, when butterflies are flying in the sky, then the Newton's third law helps them. How means? When they are flying in the sky, then the air pushes their wings upward like this, and the wings of the butterfly pushes the air downwards like this. So, this action and reaction combines help the birds and butterflies and insects to fly in the sky. Okay? How is this friends? Is it nice, no? Yes, it is nice. Okay. Okay, another example. What is this? This is a gun. When we press this, then the bullet comes from the gun. Yes or no? The bullet coming from the gun is the action, and this one, what is this? When we press this, then it comes back. It pulls our hand. It means this. Here we are observing the action and reaction. Yes or no? Yes. So this action and reaction helps the bullet to come from the gun. Okay friends, see on the slide, see on the chart here. If one object exerts a force on the other object, then the second object exerts a force on the first one with equal magnitude but in opposite direction. It is simply explained by the action and reaction. So, see the pictures. Yes. Now, let us see a slide. In this slide, we are going to see in one example, we are observing the three laws. Okay friends, see here, see the slide. In this slide, we are going to observe the three laws of motion. Okay friends, it means here for every action there is an equal and opposite reaction. When a vehicle or anything moving on the road, what happens? It exerts force on the ground. Yes or no? The tides of the vehicle exerts force on the ground, and when they are moving, the tides pulls the ground back. So this is the action, and the ground also exerts same force to the tide and it moves forward. This is the reaction. Okay friends, everywhere we find the action and reaction. And see here, see this activity till it is boiling. So friends, now let us see the keywords. What are the keywords in this lesson? The keywords are inertia. Inertia. What is inertia? Inertia is nothing but the natural tendency of an object. Inertia is nothing but the natural tendency of an object to resist a change in the state of rest or of uniform motion is called inertia. And next, the other keyword is momentum. See the slide. What is this? Momentum. Momentum is nothing but the product of mass and velocity. And mass, it means weight, acceleration, the rate of change of velocity. And next velocity means velocity is nothing but the rate of change of displacement is called velocity. So friends, these are the keywords in this lesson, and let's recall what we have just now learned. Okay friends, Newton's first law. These three laws are popularly known as Newton's laws of motion. These three laws are popularly known as Newton's laws. Okay, these three laws are popularly known as Newton's laws of motion, and motion is nothing but movement, moving, and Newton's first law explains that what happened to an object when no net force act on it. It means the objects which are rest, then what happens when force act on it is explained by the Newton's first law of motion. And Newton's first law of motion is also known as law of inertia. There are two types of inertias, static inertia and dynamic inertia. Static inertia tells us that the objects which are at rest always continues to stay at the same state of rest. That does not accept any change. Just now I have told you the examples, what are the stack of books, carom coins and so on. And next, dynamic inertia. Dynamic inertia is nothing but the body, the objects are continue to move. They continue to move in the same direction until some force act on it. For example, ball, football, this one. And next friends, see here, what is this? This is the example for the Newton's third law of motion. This is example for the Newton's third law of motion. This is a rocket bomb. When we release the rocket, when we fire it, then what happens? It moves into the space by expelling some gas. Yes or no? Like this, the rocket also move into the space. And Newton's second law. Newton's second law tells us that F equal to ma. It means force depend on the mass and acceleration of an object. According to that mass, we have to apply force. Then it comes into the acceleration. Okay friends. Now, third law is also known as action and reaction. It is very simple, and we have a lot of example for the Newton's third law of motion, and we have solved so many problems on F equal to ma. And next, I will ask you questions. Are you ready to answer those questions friends? Okay, see on the slide. First, the question is, what is meant by motion? Note down the answer in your notebook. Write down the answer. Who proposed the laws of motion? And carom board is example for which law? Rocket is example for? And friends, see, did you write the answers for 4 questions? And the other question is, what is the other name of first law of motion? What is the SI unit of mass? What is inertia? Okay. Hello? Hello Sphero?
Hello?
Hello Sphero, how are you?
Hello, Sphero, I have one doubt.
What is your doubt, Sphero?
Hello, Sphero, I have one doubt.
Okay, what is your doubt?
If two objects having, if two
objects having,
20.
what?
One is 20, its mass.
Yeah, one is 20.
And another object is 30 object.
30. Okay, first object mass is
30
20
weight.
and second object mass is
Wow,
30.
which is inertia is great?
What?
Which inertia is great?
Here
Which
the 30 inertia is great.
in that object?
The 30 inertia is great. It means it has more mass, no? Okay friends, observe here. The first, she has asked an excellent question. So, the first object has a mass 20 and 20 kgs, let's think, and the second object has 30 kgs. So, the 30 kgs inertia is, here the inertia is great. This one is great because it has more mass than the first object. Okay? Okay friend? Okay friends, let's see. Don't you have any questions? Okay friends, I am very thankful to our secretary sir. Okay, we forgotten the activity, no? See here, see this activity. When we boil this test tube, when the water become very hot, then the water vapor will present in the test tube. Okay, there is no place to water vapor come for remove from outside. Yes or no? There is no place. That's why the water vapor which is present in the test tube will exert force to the rubber cork. Then the rubber cork will come forward, and the rubber cork also exerts same force to the test tube, and it's come back. Okay friends. Hello friend, who are you?
Hello, I'm Sindhu Sara from Dharmarambi.
Okay. Okay friend, what is your doubt?
Where we observe Newton's second law of motion in our daily life.
What?
Where we observe Newton's second law of motion in our daily life.
Okay. When we are pushing the desks in our class, then we find the Newton's second law of motion. How means here when we are moving the desk, it is not easy to push a person. Can you alone push the desk there in your class? No, with the help of 3 or 4 members of our friends, we will move the desk, because here the desk has more mass. So the force which is applied by us is not sufficient to move the desk. Yes or no? Yes. So here we are in our daily life, we are using the Newton's second law of motion. This physics is a very simple subject, and we have daily life examples in this physics. And friends, here in this activity we find the action and reaction. When the cork come forward, it exerts some force to the test tube, that's why it come backward. So, and friends, see here lastly, see the slide. Okay, I want to tell you a quotation of Newton's law, that is Newton. The quotation is, I do not know what I may appear to the world, but to myself, see the slide friends, but to myself I seem to have been only like a boy playing on the seashore and diverting myself in now and then, finding a smoother pebble or a prettier shell that ordinary, whistle that the great ocean of truth lays all undiscovered before me. This is one of the famous quotation of the Newton, and another one is, if I seen further, it is by standing on the shoulders of giant. So this is also one of the quotation. See friends, who is he? What is the name of the scientist? Yes, he is a Albert Einstein. He is a great scientist. He is a physician and mathematician. He was the role model for all of us. So friends, I hope in future some of our sparrows will become like Einsteins and Newtons, and they will discover so many things, and they will change our world. And friends, remember, success should never go to head, and failure should never go to heart. So if you get disappointed, if you get failure, don't get disappointed. Try until you get success, and keep smiling. And friends, I am very thankful to our beloved secretary sir, R.S. Praveen Kumar IPS sir, and I am very thankful to my district coordinator sir and principal madam and the teachers who helped me, and friends who helped me for this, and I am very thankful to everyone in the society for providing all this. Okay friends, bye, keep smiling.